students. Today we will be discussing about one of the important topic of thermodynamics, that is known as the internal energy. I hope that all of you are well. So all of you are reading very well. So this is one of the important and the interesting chapter. And also see there are some examples you will be getting from the natural sources also. Now, what is the internal energy? See, already I have given one video that gives the introductory idea about thermodynamics. Now today I shall give you the internal energy, about the internal energy. So what is internal energy? Internal energy means this is the energy which is possessed by a body. Means every object have some energy of its own, that is known as the intrinsic energy or the internal energy. So see how this energy arises, that you have to know. See, the object means that is made up of the particles or the molecules. So that the particles or molecules, they have different type of motion, just like the vibrational motion, translational motion, kinetic motion. So every motion they will produce some energy, and this also see there is the potential energy also. So the sum of all form of energy is known as the internal energy. So okay, and this internal energy means, then how can you define this internal energy? Internal energy can be defined as the energy stored within a body due to various types of motion, or the various types of motion in various directions. Okay, and this internal energy generally is represented by the word U. But remember it, the absolute value of internal energy cannot be measured. Because if we want to measure the translational motion of the object, then vibrational motion can be neglected. So that means see, the internal energy cannot be, means absolute value of the internal energy cannot be calculated. Then what can we do? We can calculate the change in internal energy in terms of the absorption of the heat or releasing of the heat, like that. So let us take an example here. Suppose in one state of an object the internal energy was the U1, and another state the internal energy becomes the U2. So the U2 minus U1, that is what the delta U. So that is known as the change in internal energy. And this internal energy is a state function, because it does not depend on the path how it has been changed. Okay, so only it depends on the initial and the final value. Let us take an example here. So I have taken some water here. Initially this water has the temperature 30 degrees centigrade. Now what I have done? I have added a Q amount of heat, so that its means temperature rises here up to how much? 35 degrees centigrade. Or let us take that T1 and this is T2. So this T2 minus T1, that would be equal to U, or that would be the change in internal energy, delta U. See, at the T1 state, whatever the energy was there, so due to the absorption of the heat, that energy increases, and this T2 minus T1 equal to Q equal to it will be delta U, or the change in internal energy can be calculated. Now see, we can heat this by using induction coil, or also we can heat this by rotating a wheel only. Due to friction, that also can raise the energy. That means see that this value will not depend by how we raise the temperature. Only it will depend the initial and the final value of the temperature. So that's why the internal energy change, or the internal energy is known as the state function. Now see, already about the work done you have read. Now today I shall tell you about the first law of thermodynamics and its justification. First law of thermodynamics and its justification. How can we explain this one? The first law states that energy can neither be created nor be destroyed. That means the total energy of the universe remains conserved. Or another statement we can say of thermodynamics, that energy can be converted from one form to the another form. Now then see, this law is formulated from some natural example. Means there is a theoretical justification only, but there is no actually practical proof. But from the human experience, or studying the different type of phenomena, this law was formulated. Now, what happened there? that in the thermodynamics, see first law, there are some actually theoretical proof which actually supports that the first law of thermodynamics. We know that a perpetual machine cannot be constructed. Perpetual machine means the machine which will work without expenditure of energy. If the thermodynamic first law is incorrect, then we would have construct this type of machine which will work without expenditure of energy. But that is not possible. That means if the machine has to work, it has to take energy from surroundings and it will convert this energy into the work done. That means the energy can be converted from one form to the another form. But ultimately what will happen? The total energy will remain conserved for a system. Now, here see the mathematical form of the thermodynamics first law I am going to derive now. Let us take that a change is taking place by absorbing heat or by work done on the system. Suppose I am just considering an object which have the internal energy U1. I have considered a system which have the internal energy U1. Now, if we consider that the Q amount of work is done on the system, it will raise the internal energy. How much? The U1 plus Q, that is the amount of internal energy raised. Now, if we work done on the system, that would be the positive work done, and that also will actually raise the energy. Now, U1 plus Q plus W, that is the total in internal energy changes. Okay, now see that in the final state, if you take that the internal energy is the U2, so U2 will be equal to what? U1 plus Q plus W. Now U2 minus U1 equals to what it will be then? Q plus W. Then U2 minus U1, that is what? The del U. Del U equals to what it will be then? Q plus W. This is the mathematical form of the first law of thermodynamics. I hope that this will help you to understand this concept, and in the next video we will be discussing about the enthalpy and other terms. And if you have any problem or any queries, you can contact with me. And you can write in the comment box of this video. Also, you can send me the WhatsApp message, and I hope that this will help you to understand. And if you like this video, then you can like, share, and also you can comment, and you can subscribe my channel also. Okay, thank you.